Leaving Cert Ordinary Level DEBmock 2020, Paper 1, Question 2. So this is a complex numbers question, and generally speaking, if you're well practiced with complex numbers, it should have been reasonably straightforward. It would be a question that you should be capable of getting maximum marks on, or as close to as possible. So let's go through the question. So first of all, we have given a complex number, Z1, and it's -3, that's the real part, and plus 2i, which is the imaginary part. Okay, they always tell you that I squared is equal to -1. So then we tell us there's another complex number, Z2, which is equal to 2i multiplied by Z1. So they ask you to get it into the format of a real plus an imaginary number, and the quickest way of doing that would be just simply to say to yourself, well, it's 2i multiplied by the -3 plus 2i. And if you multiply that out using your algebraic skills, so it's 2i multiplied by -3 and 2i multiplied by 2i. And you should remember that since I squared equals -1, an I squared term basically becomes a number where it changes the sign. So here, plus 4i squared becomes -4. And so you would be expected to write it, the real part first, and the imaginary part second. It then asks us to plot Z1 and Z2 on the Argand diagram. And it asks you to label each point clearly. That's something that some of you are not great at doing. So let's plot Z1. So -3 along the X, the real part is always the X direction and the imaginary part is the Y. So -3 plus 2i. So we have a point here. Oh, excuse me. We have a point here, which is Z1. Okay, it's the point that Z1. Sorry, I'm having problems with my button. There you go, Z1, and Z2 is -4, -6. So we have a point down here. So I want to plot a point, and that's Z2. One thing you might sometimes like to do is when you plot a complex number is potentially to connect it back to the origin using a ruler preferably. Anyway, so that's Z1, plot the point, label it, Z2, label it. So then it asks us to look at what's going on with that. So show that 2 lots of the modulus of Z1 is equal to Z2. So to some extent we need to be conscious of what modulus actually means. Okay, so in an algebraic format, if you've got a complex number, we have a real part and an imaginary part, then the modulus of that is, it's a process that's basically Pythagoras, a squared plus b squared. So if you take the real part and square it, and take the imaginary part and square it, and add those two together, and then square root your sum, you get an answer. Now, visually, what this refers to is simply the length, the distance away from the origin, from 0. Okay, so if we look working out Z1, modulus Z1, it would be simply that length that you see there. Modulus of Z2 will be this length you see here. Let's go through that process. So, Z1, okay, the modulus of that is going to be the square root of, now we have to remind ourselves what Z1 is. So let's just write this out here again. Z1 was -3 plus 2i, and Z2 was -4 minus 6i. So the modulus of Z1 is going to be the square root of -3 all squared and 2 all squared. And if I work that out, it becomes the square root of 13. So I suppose then if we consciously look at the question, it's asking for 2 lots of that. So that's 2 lots of the square root of 13. Now you can work that out, what that is as a number. Okay, the square root of 13 is going to be a number between 3 and 4. It's going to be 3.6. That's me completely guessing. The 2 lots of that will be maybe 7 point something, maybe 6 point something, more likely to be 7 point something. Okay, so separately we're going to look at Z2 and we're going to work out the modulus of that. So again, we take the 4 and the 6. You don't need to take the negative part of it. I'm doing this to be exact, but you could just do 4 squared and 6 squared. 4 squared is 16, 6 squared is 36. So we end up with 52, the square root of 52. And if you work that out in your calculator will tell you 2 root 13. So you can see you have shown, by virtue you get the same answer each time, that 2 lots of Z1 is equal to Z2. So you might want to just, as a final conclusion, just write that out again. Don't really need to, okay, but just for completeness sake, it's always good to sort of give a conclusion at the end. Okay, so there you go. And they're equal to each other. Now, then it says, what does your answer tell you about the points you plotted in this previous part? So this point here and this point here, what do our answers here tell us about those 2 points? Well, what it tells us is that the distance of Z2 is twice as far away, it's twice the distance from the origin than Z1. Okay, so as long as you are able to explain that in a format somehow. So Z2 is twice the size as a number, okay, and also the distance away from the origin. And Z1. So that page, we had 5 marks for working out the Z2. We had 5 marks for being able to clearly plot the points, etc., and label them. And then this last part, part 3, was worth also 5 marks. Now you can see you had to work a lot harder, further for this 5 marks than for the previous 10. But that's the way it works. Moving on to this sort of last part of this question, separate part, and this section would be worth 10 marks. It's asking us to do a division. So if we take Z1 and Z2 and actually write them out, so minus 3 plus 2i divided by minus 4 minus 6i, and that as a division, so you should know that when you're doing a division you have to multiply both the top and the bottom by the conjugate of the denominator. So if we take the denominator and if we just change the sign in between there, that's what we call the conjugate. So basically what we're saying is the top is going to get multiplied by minus 4 plus 6i, and the bottom is going to get multiplied by minus 4 plus 6i. This is both the same thing, and it's the conjugate of the denominator. We take the denominator, we change the sign in between the real and imaginary part. We're changing the sign of the imaginary part. And whatever that is as a complex number, we multiply top and bottom by that. So I'm now going to multiply out the numerators and get it simplified, and likewise I'm going to take the denominators and multiply it out and simplify it. So minus 3 times by minus 4, minus 3 times by 6i. We've got 2i times by minus 4. And lastly, we have 2i multiplied by 6i. So that gives me 12i squared. On the bottom, minus 4 times by minus 4 gives me positive 16. Minus 4 times by 6i gives me minus 24i. Then minus 6i by minus 4 gives me positive 24i. And minus 6i by positive 6i gives me minus 36i squared. Now, that all ties up is going to be, well, that's 12. This here is going to be minus 12. And these two here tidy up to make minus 26i. Meanwhile, here we've got 16 and we've got 36. If you remember from, I already mentioned the idea that if you've got an I squared term, you basically, it's multiplying the number by minus 1. So minus 36 becomes positive 36. Okay, and the I terms, minus 24 plus 24, basically eliminate each other. And that's the whole point of multiplying by the conjugate of the denominator. Okay, you want this situation. You want it such that the i's sort of disappear from the denominator. Now here we happen to have a situation where the real parts on the top also cancel out. And we are just left with minus 26i divided by 52. And if we do minus 26 divided by 52, we get minus half I. So the answer doesn't have a real part, just has an imaginary part. Now you may wish to write out the real part, so 0 minus half I, but it would be acceptable just to leave it in this format. Now before I finish, that was worth 10 marks. Before I finish, I'll just mention an alternative approach to that question. The smart cookies amongst you might have realised that, well, hang on a second, there's a connection between Z1 and Z2, because Z2 is simply 2i lots of Z1. So if I have Z1 divided by 2i lots of Z1, well, the Z1s cancel, and I end up with 1 divided by 2i. Now, straight away, that effectively gets you 4 marks straight away from realizing that. And then if you can then just work on that instead of doing this division, then you'll get the 4 marks. So the key thing about when you are dividing by an imaginary number, all you effectively have to do is multiply top and bottom by I. So if I multiply top and bottom by I get I over 2i squared. Well, what's I squared? It's minus 1, so I end up with I divided by minus 2, and that tidies up to become minus a half lot of I. So writing in that format of a multiple of I, as opposed to seeing I being divided. So that was question 2 of paper 1.